Hello and welcome back to Geometry. Today we will cover section 1.5, Angle Relationships, and complete the guided notes. First up here, what we will learn, we will scan through lesson 1.5 and list two headings that you could use to make an outline of the lesson. So let's see, first up we have number 1, pairs of angles here. And a key concept to support it, followed by an example. Key concept, again, angle pair relationships. And then an example on angle measures. So definitely angle pairs would be the first one. And I see the number 2. Let's go write this one down first. Pairs of angles. It's a terrible looking G. That's better. All right, and then we had section 2, perpendicular lines, with a key concept and an example. Another concept on interpreting diagrams, and that would be the end of it. So perpendicular lines is the second section. All right, now let's read through the section and prepare to match the vocabulary, or rather, we're going to label a diagram here on the vocabulary with the correct terms all fitting in this one nice little picture here. So we'll be on the lookout for those. All right, from the top, pairs of angles. Some pairs of angles are special because of how they are positioned in relationship to each other, because of their position. Interesting. 3 of these angle pairs are described below. Adjacent angles are 2 angles that lie in the same plane and have a common vertex and common side, but no common interior points. Interesting that they make that distinction. Let's see what that would look like. Examples, angle 1 and 2 are adjacent angles. Here's angle 1, here's angle 2. Next door neighbors, angle 1, angle 2, next door neighbors. Non-examples, angle 3 and ABC are non-adjacent. Ah, I see now. ABC would have, actually let's color in the interior here. So this would be the interior of ABC, whereas this would be the interior of angle 3. Notice the clear overlap there. So overlapping angles are not adjacent angles. Got it. And then what's the problem over here? Angle 3 and angle ABC, they share a side line here, but they don't share the vertex. Vertex B is not the same as the vertex on angle 3. Okay, common vertex, common side, no common interior points. How about linear pair? A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So we have adjacent angles, so this is like a subtype, non-common side, but opposite rays. 1 and 2 are a linear pair, so they form a line. It's in the name. Linear pair makes a line. Non-example, ABD and ADC. ADB, excuse me, this one here, and ADC, this one here, because this is not a straight line, or not a flat. Yeah, perfect line. They're not opposite rays. And vertical angles are 2 non-adjacent angles formed by 2 intersecting lines. Okay, so here we have intersection 1 and 2 are vertical, 3 and 4 are vertical. So notice any intersecting lines, you're going to create 4 angles in that space. So the opposite sides are the vertical angles. And even 3 and 4, there's no horizontal angles. That's not a thing. They're always vertical, even if it's side to side. The point is opposite, catty corner, not adjacent. Whereas here, AEB and DEC don't count as vertical angles. Even though they're opposite sides of the diagram, this is not a straight line. Just to prove it to you there, I will continue that line there. So they're not created by two intersecting lines. You've got just multiple rays coming out of E there. Okay, let's see if we can find some of these in our diagram. We're looking for adjacent linear pair and vertical angles. So over here, from the diagram here, one's opposite. You're looking for opposite, catty corner. So 1 and 3 are vertical angles there. The linear pair, it must be 2 angles that would form the whole line. So here's a straight line that's made of 3 angles. So we got 2 and 3, or maybe 1 and 2. 1 and 2 are a linear pair. And then 4 and 5 are merely adjacent angles. They form a pair there, or a linear pair. But notice there's still some other terms. We could further describe those. Let's see what else we have in store. Some pairs of angles are special because of the relationship between their angle measures. Okay, what about the measurements? Angle pair relationships. First off, vertical angles are congruent. Always? It doesn't say sometimes. Always. My W is having problems here. Always. For example, angle ABC, so this upper one here, and angle DBE, this one down here with the large single arc are congruent, and angle ABD and angle CBE. So these smaller ones on the left and right with the double arcs are congruent to each other. Okay, good to know. Complementary angles are 2 angles with measures that have a sum of 90. Sum of 90. Complementary. 1 and 2 are complementary here. They form that 90-degree angle there. A is complementary to angle B. 65 plus 25 equals 90. So they don't need to be attached to each other. It's just the measures. Do the measures make 90? Yes, they are complementary. Do we have such a pair here? Yes, we do. 4 and 5 are complementary angles. And then supplementary angles. Supplementary angles are 2 angles with measures that have a sum of 180. Supplementary sum of 180. So we have angles 3 and 4 over here. Notice they're making that line there. And P and Q, 120 plus 60 is 180. So angles P and Q are supplementary. You can form a linear pair. 2 angles in a linear pair will always be supplementary. Some supplementary angles do not form a linear pair. P and Q are supplementary, but not a linear pair. They're not forming currently a line. Could you pick up and move one and set it over? Sure, but right now, not a line. So the angles in a linear pair are supplementary always. So we know nothing about the individual measures, but we know both of them together. If they form that set of opposite rays, the sum will be 180. And remember that angle measures are real numbers. So the operations for real numbers and algebra can be used with angle measures. Add, subtract, multiply, and divide them. And find angle measures using algebra and what you know about, say, their sums based on supplementary, complementary, and all that. Add, subtract from 90 and 180. See part 2 for that example. Okay, taking a look at our diagram here, 1 and 2, the linear pairs are always supplementary. So angles 1 and 2 are supplementary angles and a linear pair. And we're almost there. We just need something about lines W and X. So let's continue reading. Perpendicular lines, segments, or rays that form right angles are perpendicular. Perpendicular lines intersect to form 4 right angles. Perpendicular lines intersect to form congruent adjacent angles. Well, all 4 of them are right angles. So they all have measure 90 degrees. Of course they're congruent. Segments and rays can be perpendicular to lines or other line segments and rays. So it doesn't matter whether or not you have arrows on the end of any of these. They all work the same. Right angle symbol in the figure indicates that the lines are perpendicular. And notice, even though all 4 of them are right angles, we only need to mark one of them. And upside down capital T is read is perpendicular to, for example, line AD is perpendicular to line CB. Which means in our notes diagram, lines W and X are perpendicular. Although we don't actually have the symbol in there. We're going to have to take their word for that. That's the best word that would fit. But let's just go ahead and clear that up with a little right angle box. That'll make me feel better. Okay. While we're here, perpendicular has a non-mathematical meaning. Look up perpendicular in the dictionary. List at least 5 examples of things that are perpendicular in everyday life. Okay. Let's open up the dictionary app here. Perpendicular. Vertical. Straight up and down. Oh, I searched vertical. I did not mean to do that. Straight up and down. Upright. Thanks. No, I don't want to shop now. We also have the geometric, given line or surface at right angles. Number 3, maintaining a standard or upright position, standing up. Okay, vertical, upright, right angles to things. To me, this really describes walls. Okay, anyways. Perpendicular. Upright and vertical. So we have things like walls are perpendicular to the floor, and the ceiling. I before E, except after C. That's literally backwards. Good enough. That's why I don't teach you. You know, I'm just gonna have to write ceiling. Forget it. Walls are perpendicular to the floor. What else? I'm thinking of table legs are perpendicular to the top. Table legs are perpendicular to the tabletop or desk or chair. Most trees grow perpendicular to the ground. At least they try to. What else? Looking around. Ooh, you know what? I've got one sitting on the table over there. The lines on a chessboard are perpendicular to each other. And how about, oh, of course, how could we forget? We did this in the last one with parallel. We also need we did the opposite sides of my iPad were parallel. How about the adjacent sides of the iPad are perpendicular? There we go. 5 examples. All right, let's, before we prepare for the main idea, I would like to just finish off reading the section here just to be sure we got everything. Perpendicular lines, key concept, an example, solving some algebra. What about this? In the figure at the right, it appears that line FG is perpendicular to line JK. However, you cannot assume this is true unless other information, such as the measure of angle FHJ equaling 90 degrees, is given. That's what I just said about the diagram in the notes. In geometry, figures are sketches used to depict a situation. They are not drawn to reflect total accuracy. There are certain relationships that you can assume to be true, but others you cannot. Study the figure and the list below. This is really good. I wish more textbooks would call this out. Interpreting diagrams. This is huge. What can and cannot be assumed? Here is a diagram. We got all kinds of lines zipping and zapping through here. Lots of points. Let's walk through each one. What can we assume? All points shown are coplanar. We didn't draw a little shaded parallelogram in here, so yes, these are all coplanar to the page. G, H, J are collinear. If it looks good enough to be a straight line, we'll assume that it is. We're not going to trick you with, aha, it's not 180, it was 181 degrees. Nope. Good enough is good enough for a straight line. Ray HM, ray HL, ray HK, and line GJ intersect at H. I don't really see how they could otherwise. So if it looks like they all go through the point, then they go through the point. Point H is between G and J, absolutely. L is in the interior of angle MHK. MHK is this angle. This would be the interior, and that would include L. Yes. Angle GHM and angle MHL are adjacent angles. GHM, this one here, and MHL. Yeah, notice they also, we said HM or MH both times. Angle GHL and angle LHJ are a linear pair, so definitely straight line. GHL, this one, and LHJ, yes. JHK, this one, and KHG are supplementary because they would also be a linear pair, so they're supplementary. Okay, all of that, yes, assume, good stuff. What cannot be assumed? What looks good but isn't quite guaranteed? Perpendicular lines. There are no perpendicular lines here. HM, perpendicular, HM, perpendicular, HL, maybe. I would have guessed that's like 80 degrees at the most. That's not 90, no way. Congruent angles, J, H, K, and G, H, M. Oh, doesn't that look so good? Don't those look so close? This could be, 27 degrees, and this is 26 degrees. No idea. Not congruent. Same with any of the list here. We don't know the actual measures of anything on here. Same with the segments. We have no idea if these lengths are true. They could be off by, just 1/10 of a centimeter there. And you wouldn't know it until you actually measure or are given some information about the measurements. So don't assume anything is congruent or anything is... list of statements that can be assumed is not complete. There are more special pairs of angles than those listed. Oh, coming soon to a geometry section near you. And then there's some practice there with the example. We'll go through that part 2. So let's fill out our main idea. Here we are going to summarize angle relationships by completing the graphic organizer with the terms adjacent angles, complementary, vertical, and supplementary. What do we have? We have 4 special angle pairs, 2 of them due to positioning, 2 due to their measures. Oh, hey, it's a good thing I was paying attention to that while reading. Due to position, that would be the adjacent. Let me type. There we go. Adjacent angles and the vertical angles. And due to angle measures, that would be good old complementary and supplementary. Okay, how about perpendicular lines? If the measure of angle ABC equals 2x plus 12, ABC, so this one here is 2x plus 12, find x so that ray BC is perpendicular to ray BA. If they are perpendicular, what does that mean? That would mean definition of perpendicular. Oh, we've got little boxes here to fill in. That would mean I'm going to write one more thing. The measure of angle ABC will be equal to 90 degrees by definition of perpendicular. And really what we've done here is we know ABC is also 2x plus 12. So that must be equal to 90 degrees. So I add a little substitution step in here. Then we can simplify. Wow, they just do. Oh, just simplify from there. You've got this. Okay, all in one step, solve for x. Subtract 12. 90 minus 12 is 88. Nope, minus 2 leaves 88. Minus 10, 78. And then divide by 2. Half of 70 is 35. Half of 8 is 4. 35 plus 4 is 39. So x will be 39 degrees. Okay, that wasn't too bad. Helping you remember. Look up the non-mathematical meaning of supplementary in the dictionary. How can this definition help you remember meaning of supplementary angles? Well, we'll try it. I don't know that we'll get to supplementary. I could look up supplementary angle specifically. No, I want the non-geometry. Adjective. Also supplemental, of the nature of or forming a supplement. Thanks dictionary. Additional. Person or thing that is supplementary. Okay, what's a supplement? Forming a supplement. Something added to complete a thing. Part added to a book or document, part usually geometry. Yes, the 180. Okay, something added to complete a thing. Supplementary, so added. Supplement. Something added to complete a thing. What are we trying to complete? Let's call it the straight angle. Is the complete (180 degrees). So we just need to remember that 180 is the complete portion that we're trying to create. So supplements will form that. Okay. And I think that'll do. This concludes the guided notes for section 1.5. Come back for part 2 to complete the example problems from the section. So long, farewell, enjoy the rest of your day.